Which of the following expressions are equivalent to 3x minus 20 for all values of x? And it says choose all answers that apply, and they give us 3 choices. So like always, pause this video and see if you can work through it on your own before we work through it together. All right. Now the way that I would approach this is I would try to manipulate these expressions and see if I can make it equivalent to this expression. Another way that you could do it that might involve a little bit less algebra is to just try out values for x and see what 3x minus 20 would be equal to and try out these values. Now, that might be a little bit more spotty. It depends on what values you pick. So let me do it the first way, and then we can do it the second way if you're interested. It's not as robust. So the first way is let's just rewrite this and try to write it in this form. So I would first try to distribute the 3 over the x minus 7. So that's going to be equal to 3 times x, which is 3x, minus 3 times 7, which is minus 21. So all I did is I distributed the 3 on the x minus 7, and that's 3x minus 21. And then we have plus 1. Now what is negative 21 plus 1? Well, that's going to be equal to negative 20. So this is going to be equal to 3x minus 20, right? This is exactly what we originally had. And since we did it algebraically, we know that it works for all values of x. So we like this choice. Now let's look at this one. So once again, we would probably want to start by distributing the 3. So 3 times x plus 1, then minus 23. This is going to be the same thing as 3 times x plus 3 times 1, so plus 3. And then we're going to subtract 23, minus 23. Now what is 3 minus 23? Well, once again, we have to make sure that we're doing arithmetic with our negative numbers appropriately, but this is going to be negative 20. So this is once again going to be 3x minus 20. Looks correct again, so I like that choice. Now let's try this one. So here we have 7, and then we have 3 times this expression, so we can distribute the 3 here. So this is going to be equal to 7 plus, and then 3 times x, I'm just distributing the 3 now, minus 3 times 9. So minus 3 times 9 is 27. And so let's see, I can rearrange these. So I could rewrite it as this is the same thing as 3x minus 27 plus 7. Now what's negative 27 plus 7? Well, that once again is going to be negative 20. So this whole thing is going to be equal to 3x minus 20. So actually all of these answers apply. Now, another way that you could have done it, as I mentioned, that actually would be less robust, is to just try out values. So you said, okay, let me just see what happens when x is equal to 1. So if x is equal to 1, then this one right over here would be 3 times 1 minus 20, which would be negative 17. And then over here, you would have 3 times 1 minus 7, so that would be negative 6. And then 3 times negative 6 is negative 18, plus 1 would be negative 17. So that would actually look pretty good for just the case of x equals 1. But once again, that wouldn't necessarily make you feel good for all x's. And you would be able to do the same thing with choice B and C, and you would get back to negative 17. But once again, this method is not as robust as just being able to algebraically manipulate these choices and see if you can make them equivalent to 3x minus 20.